In this video, we'll try to solve the median, mode, arithmetic mean, geometric mean, and harmonic mean. So, in the previous video of the central averages and measures of central tendency, we have gone through the all the formulas, etc. So, directly, I will show the examples of the how to calculate the arithmetic mean for grouped and ungrouped data with different methods, etc. So now let's take the example of the arithmetic mean x1, x2, x3. So for an ungrouped data, summation of x by n is a formula. So the data set values summation by divided by n number of values. So for example, if you take the arithmetic mean here, so if you consider the data is 2, 4, for an ungrouped data, the data set is 2, 4, 6, 8, 10. These are the values. So now the formula for this is, so we know x1 plus x2 up to the xn by n. Now the calculation is simply just you are given a calculator in your examinations or everywhere in the for the statistics. So you can use the calculator everywhere. 2 plus 6 plus 4 plus 8 plus 10. 8 plus 10. So you should use that. It comes 30 and number of values are 1, 2, 3, 4, 5. So by n. So 30 by 5 is 6. So this is the value of your arithmetic mean. So here you should put it in the brackets when you are doing in the Excel. Otherwise, a Bodman. Uh, 2 plus 4 plus 6 plus 8 plus 10. 30 by 5, 6 are 30. Sorry, I have put here 6, 5. So this is your value. So this is how you calculate the arithmetic mean. And this is for ungrouped data. Now comes to the ungrouped data. So grouped data is blind spotters. You will have a frequency of it. For arithmetic mean or harmonic mean or geometric mean, if a frequency is given, you need to find out the midpoint. Midpoint is nothing but your class interval is there, right? 0 plus 5 is 5 by 2. Then that becomes the 2.5. So for all the means, you need to calculate the midpoints, which is called xi. So you know the formula for the arithmetic mean for the geometric group data is something like this. Fi f summation of Fixi by summation of Fi. This is a formula. Earlier for group data, it is summation of x by n, and for group data, that is ungrouped data, and group data is summation Fixi by summation Fi. So if you know this formula now, so what did I say? Xi is nothing but your you need to find the midpoints for all means. For a grouped data, when a frequency is given, you need to find the midpoints. Midpoints are nothing but your class interval, lower class interval plus higher class interval, plus you need to do 0 plus 5 divided by 2. So that gives you 2.5. Similarly, 6 plus 10 divided by 2. Like this, these values you will get. Example, 0 plus 0 plus 5 divided by 2. It becomes 2.5. Similarly, you can do the similar formula for all these. So now, what is the formula? Summation of Fi into Xi. So summation of Fi, summation of Fi and summation of Xi. So now Fi is what? 3. These are called Fi's and these are called Xi's. midpoints, you can put a column here and write your exercise. So 3 into 2.5 plus 5 into 8 plus 2 into 13. That is a summation of Fi, Xi, you have to do it. So this and divided by summation of Fi. Summation of Fi is nothing but your 3 plus 5 plus 2. So 5 plus 3, 8. 8 plus 8 plus 2. So the value becomes the summation of Fi 10. So 8 plus 2 is 10. So now this value 7.5, 3 into 25, 2.5 is 7.5, 8 fives are 40 and 2 13s 26. So do this 73.5 by 10. So you will get 7.3. You can always use your calculators. This is you can use a normal calculator. I am trying to explain few of the examples using the Casio calculator with the FX series with ES9991 series. I have downloaded this as an emulator and I can show you this in the future problems. These are the simple ones you can either do in your normal calculator, or these doesn't need a calculator, to be frank. But if you need it, you can. These are the simple symbols, just addition, plus, and division. Wherever you have a logs or signs or something like that, that time I will try to show how to use a calculator. So this is about the arithmetic mean. So I showed you the arithmetic mean for a group data and ungrouped data when a frequency is given. You can use this is which is a summation of Fi Xi divided by summation Fi is nothing but your direct method. If you want an assume method also, I didn't cover here this example, but I can show in the next video. For now, for group data and ungrouped data, how to calculate arithmetic mean, and when a frequency is given, an arithmetic mean is completed. Next comes the geometric mean. So what is a geometric mean formula for ungrouped data and grouped data? Let's understand, which we understood in the previous thing. So if you take this geometric mean, the formula for geometric mean for ungrouped data is nothing but your root of, you can call it a product of all the numbers divided by meaning power of to the power of 1 by n. And alternatively, it can call as exponential of 1 by n summation of log xi. So this for grouped data, the formula is exponential of summation of fi log xi divided by summation of fi. I will use the calculator while doing this formulas for both this. This can be also, this formula can be written also root of nth root of, if you find out, you can find out the nth root of product of all the values. That also, the same formula you can apply. You can either use I is equal to 1 xi, product of all the numbers, whole to the power of 1 by n, you can use, or you can use the uh, formula like this, which is the geometric mean is exponential of 1 by n summation log xi. So 3-4 methods you can use. But in this video, I will show to the root of nth root of product of all the grouped ungrouped data values. That example I will show. In future, I will show the rest of the methods to do this, like log xi, etc., all those. And this is a formula for group data. So summation, exponential of summation of fi log xi by summation of fi. Let's go to the Excel, understand the geometric mean. So this is what I meant. Nth root of product of x1, x2, xn. So now geometric mean, either this formula or that formula you can apply. It's the same, meaning is same. So now let's take the example. Find the geometric mean of 2, 4, 8 and 16. So 2, 4 and 16. So what you have to, n value is 1, 2, 3, 4. So n value becomes 4. That is your first thing. And step one is you have to write your formula. And third one is now multiply according to the formula x1 into x2 into x3 xn. So 2 into 4 into 8 into 16 is 1024. Now take the fourth root. Why fourth root? Because n value is 4. So fourth root of 104 is 5.65. Now let's use the calculator. How to use the nth root of the thing. So let me explain. So here you have a calculator. So now according to our geometric mean, what is that? 4 root of 104. So now where is our formula like nth root of number? So if you see here, it is an a Casio calculator which is FX series, and ES9991 is a model. So what you have to search is here. I'm not explaining everything right now. Whatever is required for this geometric mean, I'm trying to explain you. So here, if you see the yellow color symbol here, small square with the root of the number. So this is the symbol we wanted because this is fourth root of, but what is it in color? It is in yellow color. So to get it into the yellow color, you have to use shift color. So wherever you have this red color, alpha is there, no? Wherever alpha is there, that particular value will comes. If you use yellow color, that value, that formula will work. So here you have modes, then it comes the blue color and normal values, all those mode setups, etc. All those are there, which I'll explain bit later. For now, we have fourth root of 104. So now shift. So your shift is on. If you observe here, shift is on. So now what is the value here? So this is a formula you want. So fourth root of. So now 4 you have typed. Now use the up arrow and down arrow and place the cursor. When you use the arrow on the left hand side or right hand side, whichever you are facing, for me it is right hand side. So now you type 1024. 1024. If you type 1024, your value will become, geometric value will become 5.65. So if you observe here, so that's a value 5.65 is your value. So that's a model to do it. I will explain further examples in future with the formulas which we have used, like only to the power of 1 by n, or a summation of log xi. I will anyway in the group data I will show it, but it is simple. You do the product and use the 1 by n. Here only you have 1 by n model. 1 by n you have to see where it is, then you can use the 1 by n value also. Okay, I can show you with the example there also. So if you have this e to the power of, this is exponential, but 1 by n is a different thing. I will show with an example. Okay, for now, let's move to the next example, which is for grouped data. Okay, now we finished for ungrouped data. For grouped data, so as usual, you will get the frequency. It's a blind rule to follow for any mean, whether it is an arithmetic mean or geometric mean or harmonic mean. When a frequency is given, you need to identify the midpoints. Midpoints are nothing but 1 plus 5, 6 by 2, so 3. Similarly, like that, 6 plus 10. So 8, 11 plus 15, 13. So your xi values, you can put one more column here and put xi values 3 into 8 into 13. So here you can put it. Now, in our formula for a grouped data, what is our formula for grouped data? So this is a formula. Which one? Exponential of, which we have just gone through it, right? Exponential of 1 by n summation of I into log xi. exponential of, sorry, I showed wrong for ungrouped data formula. For grouped data, when a class interval is given, summation of fi into log xi by summation of fi. So now in your example, you found the xi's. If you see, xi's are nothing but your midpoints, which you have done the midpoints, which are called 3, 8, 13. Now, for this, but in our formula, what it says, log of xi, meaning log of 3, log of 8, or log of whatever we got it, the values 3, 8, 13, right? So those log of values we have to identify. So let's use the calculator again. So now where is the log here? Here the log. So no need of shift key or anything. Just press this button, log. What is the value for midpoint? First midpoint 3. So you type 3 and close the bracket, and it just equal to, you say. So you will get the value as 0.477. So if you see log of xi, so you have the value as log 3 value is 0.4771. See, right? Similarly, you have to just press the AC key, and next log value is 8. So just type log and 8 and close the bracket and say equal to. Then you will have 0.90 is a value. So now give me a second. So 0.90 is your value for log 8. Similarly, for log 13 you have to use. So log value of 13. Close the bracket and press the button equal to, you will get 1.113. See, log of 13 value, log of x3 is equal to 1.1139. Now, what we have done in this log value after identifying all the log values, so you can, for easy sake, you can use in a tabular form. For a geometric mean, if you want to, when a class interval is given, frequency need to be identified. Then summation of frequency, add this and put the value in the row. And similarly, midpoints, you can put it in a separate column, midpoint, and then you call it as log xi. Midpoints are nothing but your xi. Then log xi, one more column you put. Instead of writing horizontally like this, you can put log xi. Now, the third step is multiply Fi into Xi. Fi value is your frequency, which is 342. 3 into log of 3. Log of 3 is nothing but 0.4771. And similarly, next value of frequency is what? 4. 4 into log, log of what is our value? 8. Mid value of 4 value is, midpoint value is 8. So like that, 4 into log 8 value. Log 8 value is nothing but your 0.90. Similarly, frequency 2 into 1.1. So after doing this, you have to find out sum of, after multiplying each value fi into xi, and add all these values, because you have the formula as summation. If you remember, first you have to multiply fi log xi. So multiply f into log xi, then summation. So do the summation. Okay, summation of 7.27, all these, just add these values. You will get, you can use your calculator. It's just as a plus symbol. Just add those values, you get 7.27. Then summation of F5, as I told in the earlier, either you put it in the column wise or you do it in the row wise. For in a step wise, I have put it in a horizontal way, but you can do it in the column wise, which will be easy. You just, class interval will be there, frequency will be there, and you will have a midpoint, which you call it as xi. Then you will call it as log xi, put the values there and do the summation of fi, and multiplication also you can do summation of fi into xi. One more column you put it and do that summation as well. In column wise you can do, or in a step wise you can do. It is your comfort. Then finally summation of, so now the formula is exponential of 7.2715 divided by summation of Fi. Summation of Fi is nothing but your frequency sum. So 9. So now after doing, if you can use a calculator which comes 0.800. So when you divide by 7.27 divided by 9. Now exponential, how to use the exponential is your next thing. So wherever, see, if you see here in the Casio calculator, again I am explaining, e to the power of this yellow symbol is there. So now shift, press this e to the power. So now e to the power of what is the value you have to do it? 0.808. 808, you have to find out exponential value. Then it becomes your 2.24. So it has been rounded in your answer. So 2.25, when the values are continuously moving on, you can round the value to the previous digit to the 2.245. Okay. So this is how you have to find the geometric mean. So we covered so far arithmetic mean for a group data, arithmetic mean for ungrouped data using a direct method, and geometric mean with, there are several ways to identify, but we used root of to the product, nth root of product of the exercise. I showed the how to use the formula in your Casio calculator, and similarly how to use your when a class interval is given for a geometric mean, how to find out the midpoints and how to find out the log points and summation of Fi xi, Fi log xi. Do the product and do the summation and divided by summation of Fi. Then after that, complete formula is exponential of summation of Fi xi divided by summation Fi. So how to use the exponential value also I showed. So this is about geometric mean. Let's move to the harmonic mean. Before going to harmonic mean, let's revise the harmonic mean. What is a formula? So it is very simple example, just a reciprocal of arithmetic mean, which we did x1 for an ungrouped data, x1 to xn divided by n. So here, which is a reciprocal means n comes on the top and xi becomes 1 by xi. So this is our formula for an ungrouped data, and for a grouped data is just summation of Fi, where you do the frequencies summation and use that value, and summation of Fi by Xi. So you do the separately F1 by X1, F2 by X2, like that you do it and do the sum. That is a for a grouped data. Let's quickly go to the example. Okay, so harmonic mean. So here the data set is 2468. Formula is, which I told, n by 1 by xi by 1 by x2 to 1 by xn. So just apply this. Use the calculator, Casio calculator, very easy. And how many values are there? 4. 4 divided by what is 1? 1 by x1 is 1 by 2, 1 by 4, 1 by 6, 1 by 8. So what is the value? Half value is 0 0.5. 1 by 4 is 0.25. Similarly, 1 by 6 is 0.16. Like this you do and 4 by 1.04 it will come, and you can use a calculator and get the value of this. This is the simplest form of harmonic mean when a data set is given for an ungrouped data. Let's move on to the grouped data. Grouped data means blind rule is just find the frequency, sum the frequency, find the midpoints. Midpoints are very important up to mean. All means should have any midpoints, which is called xi. So nothing but midpoints is nothing but your class interval. 0 plus 5 divided by 2, you will get 2.5, and similarly 6 plus 2 divided by 2, you will get 8, and similarly 11 plus 15 divided by 2, you will get 13. These are the midpoint values. Our formula for the harmonic mean is summation of Fi divided by summation of Fi xi. Now you have Fi, you have xi. and you need to do that similarly. So now summation of Fi is nothing but your frequency addition. What are the frequencies given if are in your class interval? 3 plus 4 plus 2. So do the summation, and for each value 3 by 2.5. So Xi is for midpoints 2.5, 8 and 13. For each value 3 by, for each frequency F1 by Xi. Similarly F2 by X2. F3 by X3. You do it and use the calculator and derive the formula, which comes your HM. HM is nothing but your harmonic mean. So the blind concept to remember for any means, either it is arithmetic mean or geometric mean or harmonic mean, when a class interval is given, a midpoint need to be considered. A midpoint is called as an xi, where you will use a class interval and divide by 2, and that becomes your xi. Only for your geometric mean, you in your formula, you have a log xi. That's why you will use the log xi. But for the rest of the arithmetic mean or harmonic mean, you don't have log xi or exponential value, nothing. So no need to use your calculator. Just a small plus division and division. That's all. Plus and division are required for your harmonic mean and arithmetic mean. Now with this, we are completed the all the means, different types of means in under the mathematical value. Okay, mathematical division. Now let's move to the positional values, which are mean and mode and median. So let's understand mode formula from your uh, for group data and ungrouped data. Then let's take the examples of the mode. So directly here, for the ungrouped data mode value, we did not discuss in the previous video, because mode is nothing but your definition says the most repeated value, which is repeating the value is called the mode. So now, so when a data set is given, just find the repeated value and that becomes your mode value. Now let's understand for the group data what is your formula for this. So mode is equal to L plus F1 minus F0 divided by 2F1 minus F0 minus F2 into H. So L is your lower class, lower model class. So basically for a group data means you will have in a class interval. So first class interval, the value, lower value will become your lower model value, the model class. So L is that. So 0 to 10 means 0 will be the model class. Similarly, if it is 10 to 15 means 10 will be your model class. Then F1, frequency of a model class. F0, frequency of a class before model class. F2, frequency of a class after the model class. These three have an what is it, linking between the identifying F1, F0, F2. So first you need to find out the frequency of the model class. Frequency of the model class means highest number in the frequency. That becomes your F1. And above and below becomes your the class after it becomes F2, and the class which model class will become before becomes your F1. That's all. And class width is nothing but your height, H. So let's go to the example and see the mode. So now directly let's move on. So as discussed for the ungrouped data, which is the most repeated value, 8 is a repeated value. By seeing the data set, you are able to understand 4 also is a repeated value. However, 4 is repeated only 2 times and 8 is repeated thrice. So 8 becomes your mode value. That is a direct example for the mode to identify for an ungrouped data. Let's take the grouped data. So now this is a group data which is given 0 to 5. Frequency is 2, 5, 3. And 6 to 10, like this, frequencies are given. So now mode is equal to L plus F1 minus F0 divided by 2 of F1 minus, you have to carefully observe the brackets because BODMAS rule will apply. You cannot do 2Fi minus like this. If you do it, your calculation will be wrong. So please observe the brackets where it is open and where it is closed. So L plus, open the bracket, F1 minus F0 divided by, open the bracket, 2F1 minus, close the bracket there, and minus F0 and F2 into H. Now, as discussed earlier, lower boundary of model class. So 0 to 5. So 5 is your lower boundary of model class. 0 to 5 means you should take 5, not 0. Earlier, by mistake, I told 0, I think, in the previous conversation. So take the 5 value as lower boundary class. And next comes the F1. F1 is the highest frequency, which becomes your model class. So F is nothing but your 5. F1 is the frequency. F0 is previous, meaning F0 becomes your above value and below value will become the F2. So whatever the highest frequency is called F1, and above line you call it as F0 and below line you will call it as F2. So, and finally H becomes the your class width. So class width is nothing but 5 here, which is coming your 5, it's not frequency, it should be a lower boundary value. We'll take another example and see that also. So now apply the mode formulas. Same, L plus 5 plus F1. So F1, same, apply this into the brackets and derive the formula. You will get the mode value. Just, it is very easy to apply 2 into F1. F1 is your 5. 2 5s are 10. 10 minus 2 minus 3. So 10 minus 5 becomes 5. 5 plus 3 by 5 becomes 8. Total becomes the value to 8. Okay, mode, hopefully you understood. Mode value is nothing but what you have to take, highest frequency will become your F1, the above line becomes the F0 and below line becomes the F2. So you know F1, F2, F0 from the frequency. L is nothing but your model class. Height is nothing but your class width. That is also 5. So not frequency, this is a 5. Okay. That's all about the model class, and apply the mode. You will get the formula. These are all again plus and division, and in brackets, just apply the bond mass, use the calculator and get the value. Now let's move to the next concept, median. So let's take the median formula for ungrouped and grouped data. So we know for median, for ungrouped data, if a data set values are in even number or in odd number, we have to follow two things. Median means blind rule, you have to identify cumulative frequency when a class interval is given. That how you do in a for in a mean midpoint, how you do it. First, median means a cumulative frequency when a class interval is given. That's in a first rule number 1. And second one, for an ungrouped data, if you want to find out the median value, for if in a data set is in a even data set, then you have to take two values, middle two values, because you don't have the exact middle value. When your data set is in odd value, n plus 1 by 2. So n, the value of that position middle value, you have to 2, n plus 1 by 2. And similarly for a even data, you have to take the two values, value at the position n and value, two values. Though you have 6 numbers, if it is 6, middle values will be two values. So take those two and do it. So this is for an ungrouped data, this formula applies. And for a group data, this is the formula. L plus n by 2 minus cumulative frequency by frequency into H. So this is what I am telling. All in your means, you have done the midpoints. Exercise you did for means, mean, geometric mean, arithmetic mean for group data, harmonic mean, always you did exercise. Whereas when it comes to median, you don't go with an xi, you will go with an cumulative frequency. What is cumulative frequency? We have already know what is cumulative frequency. What is that cumulative frequency? Add the class interval will have a frequency. The same class interval for the first row will remain same, but from the next row onwards, you keep on adding to the next frequency data value till the data set ends. I'll show it in an example. So that is called cumulative frequency and frequency. All these while we used summation of Fi. Here, no summation of Fi is just F into H. What is F? Is frequency of the middle class, median class. So what is median class for the frequency also is a tricky thing which we will understand in the median. So now let's go to the example. So for ungrouped data, the data set um, is given. So whenever you do, you have to find the median. First, you need to put it in a sorting order, ascending order, from small to the larger number, then find the middle value. So now in your data set, what is your data set? It is 1, 2, 3, 4, 5, 6, 7. 7 is an odd number. So automatically your value is, median value is just 5. For this is a simple example. So your data, so since n is equal to 7, so we have n is equal to 7. The median is the fourth value in order of the data set. So the middle value is 5. So whenever the data set of an value is odd number, the middle value will become your median until unless you put it in the sorting order. So first one is easy. And when next comes, whenever you have an even number, which I told you, you have to do the addition of the two middle values and divide it by 2. Then you will get the median value. Two values are given. I missed to give that example. In future video, I'll give that example. In miscellaneous video, I'll do for all these. After finishing quartiles, percentiles, and deciles for the central measures of central tendency, whichever are not covered, like assume method is not covered, and similarly in geometric mean, you wanted to use product of the exercise to the power of 1 by n, something like that. All these different variations I will do in a separate video to explain this in detail. For now, let's move on to with the given examples which are quoted before. So now for grouped data, so which I told, which is very important, is cumulative frequency. See, I wrote in the horizontal way, you can put, as discussed in the means, you can put one more column here, just put CF. CF is nothing but 4 plus 6, 10. 10 plus 2 becomes 12. So you need to add one after the other value you in the cumulative frequency. So the CF is ready. Now, if we know the formula is N, L plus N by 2 minus F by minus CF here, not F, cumulative frequency by F into H. So L is, we know, the median class. So lower boundary of the median class. So we know lower boundary for the median class is 5. And N is equal to 12. N n by 2, n is equal to 12. So you need to add this frequencies, you will get 12 as a value. So summation of a frequency is 12. Next comes your F. F is nothing but your cumulative frequency before median class. Now, this is an important thing which you have to understand here. What is the highest median frequency in this median class, in the frequency given? 6. The above line becomes your, 4 becomes your model class of the median. Frequency of the median becomes the F is equal to cumulative frequency of the before the median class. 4 it becomes N, we understood. But what is that? You need to identify the highest frequency, and above line will become your cumulative frequency of before the median class. F becomes your that value. Okay. And frequency of the median class is equal to 6. Highest one is 6. F is equal to 6. Now next take the highest class, which is 5, which is a part of 5. Now just apply the formula, just do the plus and divide, you will get the value. This is how you identify the median. So with this, I completed mean, median, mode, arithmetic mean, geometric mean, everything. So further session I will take with the different examples. So for median, try to get the rules for it. For mode, it's just a simple thing. You need to understand F0, F1, F2. F1 is nothing but your highest frequency. F0 is nothing but above that. And below is F2. Right? You have this. Now you apply that. That is a mode for the when for group data. For median means you need to identify cumulative frequency and you need to find the highest frequency. Above line becomes your frequency model class, and that above the frequency, that's a key in this. For median mode is a repeated value, and you understand lower value, and h, everything. I will make you understand with the different examples in the next thing. And next comes the harmonic mean, which is very easy. Again, summation of fi by summation of fi xi, which is a reciprocal of your arithmetic mean. Arithmetic mean also and geometric mean, which I have explained you through the logs and through the root of nth root of the product of the xi values. So with this, we have covered all one example for each value, each central tendency values. Any clarifications, you can comment on that. I can explain with more examples. That's all then.